Hi, I'm Kelsey Campbell. I'm a graduate research assistant in the Agricultural and Resource Economics Department. My project was on how farm and farmer characteristics affect what percentage of cotton land are in crop rotation and what percentage of cotton land uses cover crops. This isn't what I'll be doing for my thesis, but it is similar as I'll be looking at some of the same best management practices and perhaps using some of the same statistical analysis, so I did find it helpful. A little bit of background about my project. I used survey data from a 2013 survey of southern cotton producers in 14 states. We got back 1,811 responses, so a pretty healthy number to work with. Georgia, North Carolina, and Texas had the largest number of responses. They have a really high number of cotton producers. And Mississippi, North Carolina, and Tennessee had the highest response rate. So the real aim of the survey was to gather information about precision farming techniques, but it also asked about crop rotation and cover crops in separate questions. Each best management practice was queried about whether or not it was used, and if it was used, on what percentage of cotton land. Farm and farmer characteristics were also asked about. These include things like age, income level, things like that, and it's really these two bullet points that I was concerned about for my research. This region has been in agricultural production for many decades, and this means that producers face some obstacles, including soil compaction and erosion, and these things can have a negative impact on yield and the environment. So the objective of my research was to determine how various producer and farm characteristics impact the percentage of cotton land producers rotate with other crops, and how much of this land uses cover crops. Before I got started, there were a couple things I had to do. First, I had to cleanse the data, which for me really meant deleting invalid responses. So for example, if somebody said they did use a best management practice, but then they went on to say they used that best management practice on 0% of their land, which happened a couple times but wasn't a huge problem, so I still had a lot of data to work with after this cleansing was done. Next came the selection of the questions I would use as independent variables. Ultimately, I chose these questions. So, do you own livestock? What is your age? Do you use precision farming techniques? Do you use variable rate technology in your cotton inputs? What percentage of your income comes from farming? What is your highest level of education? And what is your annual household income? From here, a bit more data cleansing went on because the education and household income questions asked respondents to select from 6 predetermined ranges. So a dummy variable was used to identify respondents with an associate's degree or above, and then another dummy variable indicated if the respondent had a household income of greater than $150,000 a year. These variables were what was used in the model. You can see an example of a survey question, and other questions were formatted in a similar way, though they may have just had a yes or a no box, or asked the respondent to indicate a percent with no preset range. Once the independent variables were selected, I checked them for correlation issues, and that didn't turn out to be a problem, so I began to run my models. Kind of skipping to my final result in order to facilitate a comparison, I ended up going with a bivariate Tobit model. This means I had two dependent variables, percentage of cotton land in crop rotation and percentage of cotton land using cover crops. A Tobit model is designed to censor from below and above, so it estimates a linear relationship between variables when there is either a left or right censoring of the dependent variable. Because my model's dependent variables are percentages, I needed a lower bound of 0 and an upper bound of 100. Multivariate Tobit models are better fitting than separate Tobit models when the error terms are correlated, which seemed likely given my data set and what I was looking at, but didn't actually turn out to be true, as the significance level for the error terms was 0.34, so not statistically significant. However, based on what I understand, this does not mean I can't use a multivariate Tobit model. It should still be valid. However, separate Tobit models would also work in my case. And by multivariate Tobit models, it just means I have multiple dependent variables, in my case 2, so it's a bivariate Tobit, whereas single Tobits of the same data to run the same model would have the same independent variables, but one dependent variable each. Full disclosure, I use SAS instead of R in my analysis, as that's what I'm going to be using for my thesis, and it's what my advisor prefers. So with this code, I produced these results. Alright, looking first at the independent variables relationship with the crop rotation dependent variable, we can see that 4 variables were significant, 3 at the 0.1% or 0.1 level, and 1 at the 0.05 level. The ownership of livestock and the use of a computer for farm management were positive, meaning that farmers who own livestock and used a computer for farm management are more likely to have a higher percentage of their cottonland in crop rotation. Then the age variable and the variable rate technology variable were negative, meaning that older farmers who use variable rate technology are more likely to have a lower percent of their land using crop rotation. Moving on to cover crops, we have 3 significant variables which are all significant at the 0.05 level. Again, we see age is negative, and this time the use of precision agriculture and percent of income from farming are positive. For the most part, this is what I would expect, especially with the age variable. That usually throws up a negative coefficient when you're looking at things related to adoption of VMPs. A lot of times older farmers are less likely to adopt or adopt at lower rates. So it's also not surprising that computer usage, precision farming, and income from farming are positive. That's pretty consistent with the literature as well. The first alternative method I looked at was just your basic ordinary least squared analysis, and I knew going into it that I wasn't going to love the results for a few reasons. Namely, my data had results of either a positive number or a 0. That is, a negative value didn't and couldn't exist because we were talking about a percentage of land, so it had to be between 0 and 100. This is an issue when using an OLS regression because an OLS linear model may predict a negative value for the dependent variable. For that reason, I really should use a model that restricts the predicting, hence my use of a Tobit. But I was just sort of curious, so I ran an OLS with this SAS code. And these are my residual charts, so not great. And this is my output. As you can see, this time there's only 1 significant variable for crop rotation and 3 for cover crops. And while they're consistent with the variables of significance in my bivariate Tobit, I really wouldn't be satisfied with these results as my final conclusions. Next, as what was sort of an alternative statistical analysis to my bivariate Tobit, I decided to run 2 separate Tobits, really just to see if the results were consistent with my bivariate model. The separate Tobits would still restrict my predictions to be non-negative values, so I felt better about it than the OLS I had just run. Using these codes, I got these results, and I see the same significant variables as in my bivariate Tobit, and they're all significant at the same level and have the same sign, so no real new conclusion, but it was just kind of a confirmation for my bivariate model. Just a quick recap of everything. I ran 4 separate models, bivariate Tobit, an OLS regression, and 2 separate Tobit models. The bivariate and the separate Tobits had very similar output with 7 significant variables each total, and the OLS had 4 significant variables. Since these are non-nested models, the goodness of fit values themselves aren't really meaningful, and I didn't include those here. In conclusion, I decided to write my paper on the bivariate Tobit model and its results, and with that model, I concluded that younger farmers who own livestock in addition to their cotton land and use a computer for farm management and that don't use variable rate technology have the highest percentage of their cotton land in crop rotation. And then younger farmers who use precision farming and have higher percentage of their annual income coming from farming have the highest percentage of cotton land using cover crops. That concludes my webinar. Let me know if you have any questions or suggestions.